All right. Who can raise their hand? Please tell me what is the definition for sine. Yes, thank you. Wait. Yes. Okay, everyone. The sine is the opposite divided by the hypotenuse. Remember, we're looking for that ratio. Remember, all of these are ratios. All right. Anybody have cosine? Yes, Abby.
Adjacent over hypotenuse.
Sweet. Yes, adjacent over hypotenuse. Very good. Adjacent over hypotenuse. And then the last one, the last ratio, yes.
Opposite over adjacent.
Beautiful. See, I knew you guys had it. Opposite over the adjacent. Very, very good. Those are the three basic trig functions that we've been working with, and those are the definitions, all right? Okay, now we're going to move into something that's a little bit different. We're going to move into something that's called solving a right triangle. Solving a right triangle. When you solve a right triangle, you need 6 things. And that sounds like a lot, but really it's not all that bad. So let me write that down. When you solve a right triangle, you need 6 things. I'm going to tell you what those are. You need 6 things. Okay, now, if it's a triangle, can you think of what a triangle has that could be part of the things that we need?
Sides.
Sides? How many sides does a triangle have?
3.
Got 3. Ooh, there's half of the things that we need right there.
Angles.
And what was the other one?
Angles.
Yes, you got to figure it out. There you go. Whenever you solve a right triangle, you need 6 things. You need 3 sides, and you need 3 angles. What do you think about that? Is that easy, medium, or hard? That's easy. You need 3 things. 6. You need 3 sides and 3 angles. So whenever the directions are asking you to say, hey, solve this right triangle, what they're really asking you for are, hey, please give me all 3 sides, and please give me all 3 of the angles. Does that make sense? Yeah. Okay. So that's what solving a right triangle means. Let's show an example of how we can do it. It looks like this. It says solve this right triangle. So take a moment. Doesn't have to be pretty, but put this right triangle on your page. And can you tell me, just by looking at it, do we have any of the things that we need already? Yes. We do. We have them. In fact, we have half of the things that we need already. So wasn't that nice of them? They gave us half right away. How cool is that? Okay, so take a moment, check your neighbor's work, make sure they have. What I'm going to do is I'm going to write this down over here on the right-hand side. I'm going to say, well, I know I need to get all of my sides. And then I know I need to get all of my angles. Okay, so let's list all of my sides. Name one side. What do we call it? Yes. AB. Side AB. Do I know what that is? It's 8. So I already know that one. What's another side? BC. Do I know that one? Yeah, it's 10. And what's the other side? AC. Do I know that one? No, I need to get that one. Okay, let's look at the angles now. How would you describe this angle here? Angle A. Do I know what angle A is? No, I don't. How would you describe this angle over here? Angle B. And do I know angle B? I sure do. That's 90, huh? That's easy. And then the last one, of course, is angle C. And do I know that one? No. So as you can see, I need to figure out 3 things here. My 3 highlighted spots. Does everyone understand what we're doing, where we're going with this? Yeah. Okay, so what's the easiest thing to get? AC. Why is AC the easiest thing to get? Because why? You guys all said AC right away. How come?
Wait, do you have to do like that 180?
I'm not sure what that is. Yeah, Ursula, yeah. You can use the Pythagorean theorem. So let's go ahead and do that. So, what is the Pythagorean theorem? Okay, a squared plus b squared equals c squared. How do I apply that to this, though? 8 squared. 8 squared plus 10 squared equals ac squared. All right. Okay, Jordan, how much is 8 squared? 64. Jordan, how much is 10 squared? No, 10 squared. Yeah, 100. There you go. That's all right. Equals AC squared. How much is 64 plus 100? 164 equals AC squared. How do I figure out what AC is? Okay, so when I square root, don't I? So I'm going to take out a calculator here, and I'm going to figure out 64 square root I'm sorry, yeah. 164, thank you. Square root. So I got like 12.8. Is that what you guys got? Is that good? So AC is approximately 12.8. We're going to round to one decimal place. So now I can go back here and say this is 12.8. All right, am I done? No, I'm not done. Why not? Because I need the angles, right? Okay, which angle do you want to get, A or C? You want to get C? All right, let's take a look at angle C. Here's angle C. According to my trig functions, okay, which we've listed up here in the front, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, which two do I know when I'm looking at angle C? Which one is this? That's the opposite. Which one is this? Adjacent. Which one is opposite over adjacent? Ding, 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 ding. Tangent, right? So here's what we're going to do. We don't know what the angle is yet, but what we do know is that, I'll use in blue here, we do know that the tangent of angle C has to be the ratio of what to what? 8 to 10. Very good. So can someone please tell me, how much is 8 divided by 10? Oh, very good. So the tangent of angle C is 0.8. But that doesn't help us, right? Because we want angle C itself. We're not looking for the ratio. We're looking for angle C. So what we have to do is kind of work backwards. So if we know that the ratio is 0.8, what angle must that be in order to get a ratio of 0.8? And there's two ways that you can do it. You can either use your calculator, or you can use that piece of paper that I gave you. So since everybody has that piece of paper, it has to be about, angle C has to be about 39 degrees. So we can go over here and say about 39 degrees. Now if you have a calculator, okay, I'll show you how to do it on the calculator as well. Everybody's calculator is different, so it'll depend on which calculator you have, and I can help you out with that in just a second here. So for those of you who have a calculator, make sure that the mode you're in is in degree mode. So mine happens to be a degree mode. I can show you guys how to do that. So I can say second tan. So second tan means the inverse to tangent. The inverse of tangent. So what angle do I have to have in order to get a ratio of 8 divided by 10? 8 divided by 10. And if we push enter, what should we expect to see, you guys? About what? About 39 degrees. Hey, check it out. 38.65. So if we round it up, are we about 39 degrees? All right, so that's pretty cool, right? For you guys who have this other type of calculator, this one here, I think you have to go, yeah, where's the second button on this thing? I don't know where the second button on this thing is. So if you have a calculator, I can come around and show you, but everybody can use the piece of paper. Okay, now, here's my next question to you. Do we have to do this again to get this one? Oh, I put the wrong angle. I'm sorry. Let's try that again. So this one's about 39 degrees? Okay, do I have to do it again to get angle A? No, there's a faster way. What's the faster way? Yes, Ursula. There you go. Let's just do 180, subtract off 90, subtract off 39, and that gives us about 51 degrees. All right, so I've caught up here. I've gotten AB is 5.4. I have AC was 5 that was given to us. BC was given to us 2. Angle C was 90. I'm curious, how do you find angle A? Who came up with the solution to find angle A? How do you do it? Okay, so you said the tangent of angle A has to be what over what? No, 2 over 5. So the tangent of angle A has to be about 0.4. So how do you figure out what angle that has to be? Go down to 0.4 in your sheet, and what does that angle have to be? Angle A has to be about 22 degrees. Do we agree? Okay, so that's about 22 degrees. How do you find angle B then? You just subtract from 90, right? And you get what? 68 degrees. Okay, do you guys feel like you can do that now? So it's kind of going backwards, right? So that's what your homework is. I think there's 5 problems from the book that ask you to find and solve right triangles, all right?